Alright guys, welcome to today's tutorial, and today we are going to be looking at Rolle's theorem. Rolle's theorem states that if a function f of x is continuous on a closed interval x1, x2, differentiable on an open interval x1, x2, and f of x1 is equal to f of x2, then there exists an at least one number x0 in x1, x2, such that f prime x0 is equal to 0. So what does it imply? That if you are given a curve, let's say you are given a curve of f of x is equal to 4x squared minus 20x plus 29 with the interval of 1 to 4. So from here, your x1 is equal to 1 and x2 is 4. So the first thing you need to do is you need to get f of x2, which is f of 4. Which is going to, if you want to get your f of 4, you simply put 4 into the equation for the curve. This is going to be 4 into 4 raised to the power of 2 minus 20 into 4 plus 29, which is equal to 64 minus 80 plus 29, which is equal to 13. Then you go ahead to get your f of 1, which is going to be 4 into 1 square minus 20 into 1 plus 29, which is equal to 4 minus 20 plus 29, which is equal to 13. So you discover that f of 4 is equal to f of 1. So you discover that it satisfies Rolle's theorem. Therefore, you can move further to get your x0. In order for you to get your x0, what you do is that you differentiate f of x. If you differentiate f of x, differentiating f of x is differentiating the original equation of the curve, which is 4x squared minus 20x plus 29. And if you differentiate 4x squared minus 20x plus 29, you're going to have 8x minus 20. Then you get your f of x0. F of x0 is equal to 8x0 minus 20. Then you put f of x0 as 0. Putting f of x0 as 0 means 8x0 minus 20 is equal to 0. 8x0 is equals to 20. Then x0 is equals to 20 divided by 8, which is 5 over 2. And you discover that f prime of 5 over 2 is equal to 0. Therefore, you say 1 less than 2.5, which is 5 over 2, less than 4. So that is it. Let's take another example. Given a curve, f of x is equals to 5 minus 12x minus x squared with the interval of minus 7 to 1. Your x1 is minus 7 and x2 is 1. So therefore, f of minus 7 will be equal to 5 minus 12 into minus 7 minus 2 into minus 7 squared, which is equal to 5 plus 84 minus 98, which is equal to minus 9. Then you go ahead for your f of 1, which is going to be 5 minus 12 into 1 minus 2 into 1 square, which is equal to minus 9. So you discover that f of minus 7 is equal to f of 1. So you say it satisfies, discover that it satisfies the Rolle's theorem. So there you go ahead to look for you differentiate f of x, which is f prime of x. Differentiating f of x is differentiating the equation of the curve, which is 5 minus 12x minus 2x squared. So differentiating 5, you have 0. Differentiating minus 12x, you have minus 12. And differentiating 2x squared, you have minus 4x. Then you find your f of x0. F of x0 is simply replacing the x at x0, so it's going to be minus 12 minus 4x0. Then you equate f of x0 as 0. Therefore, you have that minus 12 minus 4x0 is equal to 0. Then you have 4x0 is equal to minus 12. Then x0 is equal to minus 12 divided by 4, which is minus 3. So you then f of minus 3 is equal to 0. Then you see the first interval is minus 7, which is less than the x0, which is minus 3, and which is less than 1. That is the solution to that. Let's take another example. If you have a curve also, f of x is equals to x cubed minus x with the interval of -1, 1. So what do? You find your x1 is equals to -1 and x2 is equal to 1. So then you can find your f of -1, which is going to be -1 raised to the power of 3 minus -1, which is equal to -1 plus 1, which is equal to 0. Then f of 1, which is equal to 1 raised to the power of 3 minus 1, which is equal to 1 minus 1, which is equal to 0. Therefore, f of -1 is equal to f of it satisfies Rolle's theorem. So you can go further to say that f prime of x, that is, you differentiate f of x, which is x cubed minus x. Differentiating x cubed minus x, you have 3x squared minus 1. Then f prime of x naught is equals to 3x squared naught minus 1. Therefore, you can say f prime of x naught is equal to 0. So therefore, you have 3x squared naught minus 1 is equal to 0. 3x squared naught is equal to 1. Then x squared is equal to 1 over 3. Then x naught is equal to square root of 1 over 3, or x naught is equal to minus square root of 1 over 3. So x naught can be equal to 0.58, or x naught is equal to minus 0.58. Then you can therefore see that -1 is less than minus 0.58, less than 0.58, less than 1. That is how to solve it. Thank you guys for watching. Make sure you like the video, comment, and don't forget to